Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good afternoon everyone.
Good afternoon, doctor.
Good afternoon, Doctor.
Afternoon everyone. I don't know wherever you are. We in KL like PKP 3.0. So we're going to be like having a PKP Raya. Hopefully
Yeah.
it does. Just but I think it should be okay. I guess the second year celebrating Raya. I hope your spirit is still up. I know a lot of you
It's
like
gone.
your spirit's gone. Nah, like whatever it is, Raya is still gonna be on. Find a way to like yeah but yeah anyway, okay, all right, I think I better start my recording first. Okay. All right. Okay. So today we are going to be looking at tutorial 9, which is greedy algorithm. And I have posted a lecture recording of lecture for this topic. So hopefully you have gone through it. So basically, greedy algorithm is another approach that you can use to solve a problem. Okay. So for the greedy algorithm, the concept is very simple. It's just that so basically in greedy algorithm, or the steps or the solution that you're going to find, you can find the solution just by applying something like making the best decision at that point. Okay, so it's like you do not have to do any processing or any how to call that computation. All you have to do is just look at whatever that is existing and try to choose whatever that looks best at that time. Okay, so for the greedy algorithm, it normally is applied for optimization. Okay, or but typically greedy algorithm, it it's not like it is not that greedy algorithm is not useful. It's just that most of the time greedy algorithm will give you some kind of optimal global solution, but usually you will need to go and use the dynamic programming to get the best global optimized solution. Okay, so basically you need to do some kind of like computation first before you can do decision. Okay, rather than a simplistic way in greedy algorithm. But for some cases, for some situation, greedy algorithm is just fine to be used in order for you to find the optimally the optimal global solution. Okay. All right. So basically, in order for you to apply the greedy algorithm, is that it must have that greedy property. So basically, that you can have some sub condition where it allows you to sort of like add to the final solution. Okay. All right. So, question number one basically ask you about the definition of greedy algorithm. So, for question one, thank you for whoever that gave the answer beforehand. So it's going to be faster if we do this every tutorial. Then I don't have to wait for answer. So it'll be much faster. All right. So explain using your own word about the concept of greedy algorithm. So here, an algorithm that takes best immediate solution when finding an answer. The best immediate solution in this case also mean a solution that is the most optimal. Okay, so as I explained just now, for greedy algorithm, you do not have to think much. It's a very straightforward. Uh, uh, at each point, all you have to do is just try to take what is the best solution at that time. Okay, best next solution at that time. Okay. All right. So anybody else do not understand about the greedy algorithm in general? So it's like, yeah. So I also would like to mention that for this topic, we only covered the definition of greedy algorithm. We only look at the application of greedy algorithm in Huffman code, and then we apply some kind of greedy approach to calculate the activity selection, right? So those are the two examples that we sort of demonstrate the greedy algorithm. You will see more greedy algorithm in graph algorithm. I think, if I'm not mistaken, it is going to be Kruskal, the depth first search, breadth first search, BFS, DFS. So those are the some of graph algorithm that uses the greedy approach. Okay, so don't get confused about that one. Okay. All right. So optimization is the process or act that aims to make something fully perfect, as effective as possible. Or perhaps you can say that optimization is a process where you try to maximize the throughput. Meaning whatever things that you want to get in the end, you want to get the best or the maximize benefits out of the algorithm. Okay, and then see how greedy is able to resolve the optimization problem. It does that by making the optimal choice at each step. Okay. All right. So for question number one, do you have any question? Question number one, do you have any question? I know it's like uh, um, a question with a question, but yeah. So anything you want to add for question number one? Or do you have any other answer? Class?
No questions for me.
Okay. So this is very straightforward. So basically, this is for uh, um, so that you can understand what is the concept about greedy algorithm. Okay. All right. So question number two. There are 7 different activities given with their starting time and ending time. Select the maximum number of activities. Select the maximum number of activities to solve by a single person. We will use greedy approach to find the next activity whose finish time is minimum among the rest of the activity and start time is more than or equal with the finish time of the last selected activity. The list of different activities with starting and end time are as follows. Find the selected activities. Okay, so basically we have so there are 2 questions. So A, there are 7 activities with start time and finish time. So here, so the first step is sorting the activity according to their finish time. So we have 3, 6, 7. Why is it 3 and then 6, not 3, 4, 5, 6, 7, 8, 9? So 4, 5, 6, 1, 2.
No, that's why I asked the question because I was wondering.
How did you?
The way I saw this is, I think the ending time. So it takes for number 3, it takes 1 second. Right.
S is the start time. S is the start time. F is the finish time.
No, like the duration.
The duration. Okay, no, you have to sort according to the finish time.
Or like from start to end. Okay.
Yeah, the finish time. It's just that the finish, the like you sort 9, 8, 2, 4, 5, 6, 7. So because like we are trying to imagine it in timeline, you see. So basically, activity 3 finishes at 2. Activity 4 finishes at 4. Activity 5 finishes at 5, 6, and so on. So you want to know which activity finishes in sequence. Okay, so therefore, we should have 3, 4, 5, 6, 7, 1, 2.
Oh, 1.
Sorry, 2, 1. Sorry,
1.
8, 9. Yeah. Yeah. My brain is a bit muddled as usual. Like after in the afternoon, it'll be a little
Totally
bit.
understand.
Yeah. Okay. So please check. And please ask back if I said something that doesn't make sense. Okay. And then choose the first activity from the sort. Okay. And then what time activity finish and students finish time according to them. Okay, so we can start with 3. So 3 finish at 2. You can start with 4. 4 finishes at 4. You can start with supposedly you can start with 6. 6 starts with 6. Start with 6 and end at 7. You can start with 1. Possible sequence 3, 4, 3, 4, 6, 7, and 1. So it should be the second answer. So 3, 4, 2, 1. I don't know how do you get the 3, 4. You can do 6 after 4, right? And then 7, 1. Okay, so it should be the maximum number of activities is 5 if you're applying the greedy algorithm. So this one is so this is supposed to be 3, 4, 6, 7, 1. I don't know how do you
Why
get
can't it be 3? Because I interpreted the question as
3.
how do you get to the end with the least amount of activities?
The least amount, you are supposed to get the most amount of activity. For scheduling the activity, in order for you this question wants you to find what is the most activity that you can do based on this information,
Oh, right. Okay.
not the list. Because of course if you're given a set of tasks, you want to do as much as you can, right? So so for this problem, we can apply the greedy algorithm to find what is the largest set that we can have, a largest set of activities that you can have. And how you do it is based on the finishing time. So that's why when you sort it according to the which activity finishes first, because you want to fit as much activity as you can and finish it as early as you can. Okay, so that's why we get the earliest one first, and then we follow through to see whichever that can whichever activity that can fit inside the set. Okay,
So it's
here
okay if it jumps one time unit, is it?
yeah, as long as because you do not want it to overlap. The only thing that you have to make sure is that the finish time and the start time does not overlap. Okay,
Okay,
is
got
that
it.
right? Yep. Anybody else have any question about this one? It's pretty straightforward, right? Should be okay. All right. So for question B, it has a little bit of constraint because in this case, you need to have an activity starting from time 0. Okay, so which activity start with 0 is 3. Activities are out. So activity 1. Okay, repeat since that's about. Okay. So we can have, so basically we can have 6, 3. The next one is 7. And then the next one is 11. Okay, so if we do the algorithm properly, we're going to get this one. But we can also have 3, 8, and 11. Yeah. And we can also have 3, 9, and 11. Okay, so these are the 3 possible set that you can do. A 3 possible a set of activities that you can have. Okay. So it's just that if you're doing I don't know whether the original algorithm will give you the other 2. Okay, so this is just to show you if, like, let's say for example, when you sort the task. Okay, so if you're using a stable sorting, you're probably going to get the first one. Okay, 3, 7, 11, because it has so basically that is the sequence that it is being sorted. So if, like, let's say you are using some unstable sort that maybe 8, 9 changes its position, so you're probably going to get either 3, 8, 11 or 3, 9, 11. But I think it would be but I think it will go through. I think it will still have 3, 7, 11, because 7 is like it starts earlier than 8. So and it finishes sooner. So so I think if we apply the algorithm, we would definitely get the 3, 7, 11. And if we're still applying the greedy algorithm, we can still get the 3, 8, 11 and 3, 9, 11 set. Okay. Wait, 3, 7, 11. Yeah. 7, 8, 8. You get what I mean, class?
Yep.
Yeah. So how should I say it? Yeah. So yeah. Okay. All right. Okay, any question about the activity selector? Straightforward as well, right? So basically, we know the because we know that our goal for this is to find as what are the largest set of activities that you can do. Okay, and we apply the greedy algorithm, and we can we are able to select a set of activities that we can do. Okay, the biggest set of activities that we can do. So for the first one just now, we have no constraint. So we can start at activity 3 and we can finish 5 activities. And for this one, I think the lecture, if we start at time 1, we have 4 set, if I'm not mistaken, 4 activities that we can do. And if you start at time 0, okay, if like there's a constraint saying that you can start at time 0, this would be the set that you will get. Okay, the set of activity that you can do within the time. All right. Okay. All right. So for question number 3 is the knapsack question. Okay, one second. Okay, so it is the knapsack question. So again, let me try to refresh again about this problem. So the reason why we in the slide we show you the 0, 1 knapsack is to show you that uh, for this 0, 1 knapsack problem, greedy is not going to give you the most optimal solution. Okay, because basically it does not do any computation to find how to determine what are the most the maximized value that you can get by applying the algorithm. Okay, but then it can give you like at least a solution on how you can solve the problem. Okay. Do you know what is the difference between 0, 1 knapsack and fractional knapsack? So here, somebody already gave, actually there's an answer there. Taking items as a whole weight, you cannot break down into ratios and fraction. Either take it or leave it. Yep. It's not like you cannot solve it through greedy strategy. You can have a solution through greedy strategy. It's just that it is not fully optimized. Okay. You can get like some kind of solution out of it, but the solution is not fully optimized, meaning you're not going to get uh, 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 the full optimization out of out of using the greedy approach. Okay. And then for fractional knapsack, you can choose to take items based on their fraction ratio, okay, value kg, and then determine which item is the most value kg through sorting it from most to least, okay. Can solve through greedy strategy. Uh, it's basically for the fractional knapsack, it is not really greedy anymore because we do some kind of computation. So it is more towards dynamic programming already. So in a sense, you do some kind of tabulation, okay, of data, and then you do the choosing, okay. So yeah, it is still somewhat looks like it is greedy, but it's already moving towards a dynamic approach already. Okay, so yeah, so basically those are the differences between 0, 1 knapsack and fractional knapsack. So 0, 1 knapsack. So since the limitation of this problem is the knapsack that you have, so we want to make sure that we can carry as much weight as we can inside the knapsack. So that's why we are going to sort the weight, okay, from the heaviest to the least heavy. And then we try to choose the most heaviest first, and then so on and so forth, up until 100 kg, and that is the answer for that one. Okay, so basically we're going to take item 1, which is 50 kg, item 5, which is 30 kg, and then item 3, which is 20, that makes up 100 kg, and the value is 270. Okay, so this one assuming that when you sort the item, 5 comes before 7. If the position is swapped, then perhaps you're going to get a little bit more, which is a little bit less, because 7, the value is 90. Okay. All right. So fractional knapsack, you have to do some kind of computation first. So value is 1 to so for the value kg 1, 2, 3, 4, 7, 3 value per kg. Okay, according to the greatest value per kg. For 50. Item kg. Okay. Item kg. 1 is 50 kg. 7. 35. I could for the second, according to the greatest value kg, I'm not sure how do you do this sequence. So 4 to 6, you're already sorting it, is it? I think,
Yeah, I sorted
yeah.
it via a value.
Okay, so 5. So basically, you're gonna take 4 first,
Yeah.
and you're gonna take item 2, 7. Okay. All right. So basically, item per kg. So basically, you have sorted it, and then you take the highest value, and it will make up to 525. And since it's fractional, the last item, you can take only 25 out of the 30, which values to 75, and then you add it in, and then you're gonna get 525. Okay. So another answer here, we have 2, 3, 4, 5, 7. What is it mean by 3, 2, 4, 5? Oh, the item, is it? Huh.
Yes,
Why?
Doctor.
Okay. So how do you get the 2, 3, 4, 5, 7?
I
Three.
prioritize the value first, and then wait.
Sorry.
Uh, Maximize the value.
Okay. So that's why just now I mentioned to you, normally when you do the greedy algorithm, we don't really do any calculation. Okay. So in a sense, uh, and then you start with the least weight rather than the biggest weight. Greedy is like, greedy is like we want to take as much as we can first before, and then we take the next one, the next least one. Hence the name of greedy algorithm. So for the total weight, okay, so you should start with the biggest weight first. Okay, so this is where uh, 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 um, um, so that's why supposedly this one, it should start with the biggest weight, which is item 1, which is 50. Okay, where's the answer, John? So supposedly it should start with the biggest weight. You're being greedy, you have a set that can only hold 100 kg. So you want to put the most heaviest thing first inside your sack. So in a sense, you have to choose the biggest one first. Okay. So here I'm not so sure how do you get 10, 25. Can you explain again? How do you get the 10, 25 to, oh, you take the value, is it?
Yes, Doctor.
No, you're not supposed to take the value because the constraint in this case is the set that you have. So we need to look at the weight. So again, like when you look at the total value, you still have to do some computation, like, okay, so you look at the value and then you look at the what is the weight for each of the item. So so in this case, we want to, make sure that we take the largest item first. Okay. So the answer should be somewhat like the first one. Okay, whereby we take 50 and then we take item 5 and then item 3. Okay. And then for fractional knapsack, I think your answer is the same like the first one as well. So instead, you put in the ratio 1, 10, 5, 14, 4, 6, 3, and we take the biggest ratio first, which is 4, 2, 6, 3, 5, 7, 1. And then the last item, which is item, what do you have? Item 1. Okay, so because you want it to be, so item 1 cannot because it's 50 kg. So item 7, you only take 5 over 6. Uh, uh, and you will make up to 5 to 5. Okay, all right. So this is how you do the fractional knapsack. Okay, so do you have any question about this one, class? So if you take 10, 100, 170, Uh, any question about this one?
No questions.
Okay, so it's a straightforward application of greedy algorithm. Okay, so for the Huffman code, I really like doing Huffman. I don't know why. It's kind of cute, I think. I don't know how to explain it, but I think it's cute. Using Huffman code, you need to find the variable length code word, okay? And basically, what is it trying to do is it's trying to do file compression, okay? And then by finding a variable length code word, you should be able to do some kind of optimization, okay? An improvement of sound percentage of the compression value, okay? So we have this character A, B, C, D, E, F, G, and their frequencies of each of the letter. So one of the answer is this one. Have anybody got a different answer? Anybody got a different answer, or anybody
I got the
who
same answer.
same answer?
Yeah, I got also the same answer.
Yeah. Actually, oh yeah, correct. Yeah, correct. Same.
Same. Okay. So some of you may have a different answer, and that is totally fine because you may get a different tree. So in this case, whoever that is giving this answer, make sure that the one on the left is smaller than the one on the right. So I would, if like let's say you're doing it on paper, then perhaps you can actually make sure that it is so. But sometimes sometimes you just add the note, so your tree is probably gonna look different. Okay, like let's say for example, 16 maybe on this side, 27 maybe on this side. Okay, this one is 27, this one is 18. So your tree is going to look different, and when you put the zero on the left side and one on the right side, you will get a different variable length code width, okay? And it is still totally fine. You still do some kind of improvement. It's just that probably the value or the percentage may not be the same, okay? Either you're going to get the most optimized one, and so on and so forth, okay? So yeah, so basically the answer can varies, okay, depending on the Huffman tree that you created. Anybody do not know how to do the Huffman? No? All good? Class? Any question about the Huffman?
All good in the hood.
Okay, so this is a very quick tutorial. Thank you for whoever that prepared the answer beforehand. So if you want to have a quick tutorial, like if you see the link, go and contribute your answer, and then we can just discuss as we go. Okay, do you have any question about other things before we end the class for today? I think the next time that I'm going to see you is after your mid-sem break, right? I think we're going to be looking at graph algorithm. Any question? No?
No questions.
Okay, so for the previous tutorial, I'm so sorry, I totally didn't notice that we had a public holiday last week. So please prepare the answer for that one as well. So I will do like a video just to go through your answer. paste on the one that you put inside the Google document. Okay, so if you have any question, or like, let's say, for same thing like what we did, we do in class. Let's say you have a different answer like the one that we have for fractional just now. Okay, two different answer. Just put it there. Write a comment on it, and then I will try to address it in the reply video later. Okay, so hopefully by tomorrow the document is ready so that I can do the video. Yeah. Other than that, I don't think I have anything else to say apart from have a good holiday and Selamat Hari Raya. Every spirits must be up. I know I'm
Thank
sad
you.
as I cannot go back home as well. But yeah, we still we need to still enjoy the festive season. Okay, I'll see you after the break. I'm still available. You just can text me on Team if you have any question about your group project or anything. All right. So if we have no more question, I will end the class for today. All right. Let me stop the recording. Okay. And thank you very much, everyone. Bye.
All right. Thanks, Doctor.
Bye.